I'm now going to ask the three presenters to take place at the front so we can have a period of questions. Les questions sont bienvenues en français comme en anglais. Questions are welcome in English or in French. Please don't hesitate. There is a microphone there that you're welcome to walk to, but we have it is preferable if you use the microphone because we are recording the period of questions as well. And there's a microphone here that you can use to answer the questions. So, anyone for a first question?
It's too late.
No? Yes?
Okay. I actually have a couple of questions. One is comparing the Swedish pulp and paper industry and the forest industry with that in Canada and Quebec. I'm not too knowledgeable about the industry, but I have heard over the years that the industry in Scandinavia, places like Finland and Sweden is generally a lot more efficient and profitable than the industry here. That it's been using more modern equipment, better at recycling the forest and things of that nature. I don't know much about that, but I've heard these things, so I'm just curious whether there's any truth to that, and if so, can you elucidate?
Okay. So, thank you for the question. So we will answer two parts. So I will talk about in terms of energy. So yeah, it's true that the mills in Sweden are more modern. They normally have, comparing with the Canadian mills, they have a lower water consumption. So that means that they have other opportunities for heat recovery that they have already implemented. So we are catching up. So our mills are a little bit older. So we're catching up, but for the rest.
Yeah, exactly. The age of the mill is so important. It's basically everything. But you cannot do a lot also with sort of older mills if you sort of keep up and maintaining them so they do the best all the time. And that has been done also. And I've been around a long time in this business. There has been very few shutdowns. Very, very few, if any really. There has been a few in Finland, so it's amazing, I would say. And when I was running this eco-cyclic pulp mill program, we compared the average for the industry in different countries. And Sweden was okay, Finland was better because they had more modern mills, and it was very much higher in Canada and in the US in terms of steam consumption and water consumption. And it reflects the age, more or less. It's very easy. And so, yeah, that is the case. And year after year, you have a lower production cost. So, I mean, there are benefits of having a modern operation, even if you have to pay for the capital. But we've been lucky with the currencies and stuff like that. Luck is an important thing also, of course.
Thank you. Any other questions? Yes, please.
Yes, I have a question. Actually, to go back first, it's I think there's a study from a European group, and Scandinavian mills are best, and then Brazil, and then US and Canada last. So my question is for Enrique, Dr. Enrique, and you mentioned you do, for every single project, you do the entire process integration and then as a whole. When you say as a whole, you mean as a department or as the entire mill for every single project?
Yeah, no, well, the philosophy, the mindset of process integration is the complete process, the complete mill. All departments, including the utility systems. So when you find a project, that project fits into improving the overall efficiency of the mill, of the process, not just the efficiency of a specific department. So it's that. So as you answer your question, yeah, it's the whole process.
Every time. So you take all the projects.
Yeah,
and you do them.
When we develop a study, okay, we analyze the full process, and then we come up with a set of projects. So the set of projects will help us to achieve well, the maximum possible energy efficiency in a process. So there is a list of projects that need to be implemented, sometimes sequentially, sometimes they can be parallel, so you can achieve a higher energy efficiency. But all of them have to be. What we try to do is like the projects either are complementary, but not they do not. You don't have. If you choose between one of the other, then one has to give you a better energy efficiency. So that's what we are looking always.
So,
Yeah, it's important to do the whole meal analysis. Often, not always, often because often the measure will affect the whole meal. So you need to sort of compare at the same boundaries, and normally it is around the whole meal. Sometimes it's around the process. It depends really how complex the issue is. Energy is one thing, but what is more important is the total economy, and of course costs are so important, and capital, that's natural. But one thing I would like to say is that if you close the water cycles, it can be small changes. There can be enormous consequences that you cannot really predict, because there can happen really nasty chemistry. It can be really nasty chemistry. You know, kidney stone, calcium oxalate, you can have that formation in a pulp mill as well, really nasty incrustation. And you can have different kinds of incrustation in different parts of the mill for small changes in flows or in pH variations or temperatures also. So in some kinds, a very good pinch could be really dangerous for that kind of problem. So you have to have an open mind for everything that could happen.
Yeah. Well, just to add up, last thing. As I mentioned before, like to be successful, as Peter Axegård just mentioned, is you need to have a knowledge of the process operation. So, for example, something like that not happen. Like you, even though you have a project that in terms of energy efficiency work, like it will, maybe the payback is there, you will have a problem with incrustation or a chemistry problem. So that's something that it's a constraint right away, so you dig it out. So if you want to be successful and implement a project, you have to take into account those things.
Thank you.
Hi, my name is Claude Vechet. I manage a clean tech fund, and I was just curious to know what is the impact of the price of crude oil at $30 a barrel lately. Does it have any impact on the deployment of these new processes and new technology? Because most of the time the chemicals are produced the old way with fossil fuel, and spending money investing in new processes with the current economic trend on fossil fuel, does that have any impact on the biorefinery?
It depends on what kind of biorefining we talk about. If you talk about sort of bulky chemicals, then it's really tough. But if we talk about advanced materials, it is not, then it's something else. That production is rather independent of the oil price, actually. Take carbon fiber or textile fibers. I mean, it really doesn't matter very much. So it depends on the product. So, but if we go to bulk, like ethanol or some try to make different kinds of hydrocarbons, then it's really tough. Methanol, for instance, also.
Well, I think that for the time being, you know, the biorefinery in Canada is at the stage of the large pilot plant, pre-commercial pilot plant. So I don't think that prices of commodities will affect, should affect this ongoing project. I think the biorefinery economy is for the long term, and it's not really here yet. It's in the early stage of development, so we should not stop because there is a drop, a temporary drop in the price of oil, probably.
In the context of the problem of reducing greenhouse gases, the use of fossil fuels, particularly in the transportation sector, is a big issue. And I've read articles about trying to make biofuels from plant matter or whatever. In Canada and the United States, they're producing ethanol from corn, which many people view as a dubious proposition from a greenhouse point of view. Places like Brazil, they're using sugar cane, which is more efficient. But the magic bullet, whatever the people are looking for, is something called that I've heard is called cellulosic ethanol, the ability to produce ethanol type fuels from cellulosic materials, which would open up, a much bigger supply. I'm just wondering what's the state of that from forest products? Is there any prospect of getting cellulosic ethanol at a good price from that? And also biodiesel, that's another issue. I was involved in a study that was looking at how to reduce greenhouse gases and the use of diesel fuels. There's no good source of biodiesel that can be used for heavy transportation and so on like that. Is there any prospects of that coming from wood products?
Yeah, I talked to Neste recently. It's a large oil refinery making different products from the refinery in Finland. They are heavy in transportation fuels, of course. And there are different kinds of biodiesel, by the way. So and the performance varies a lot. But one problem we've seen in Sweden with certain biodiesel from fatty acids is that you get engine problems. That has been seen in Brazil as well. The chemistry is a little different than normal diesel, and the molecules are sort of nice for some microbes, so things can happen in that combination, and also properties in cool temperatures can be a problem. Ethanol has been promoted a lot in Sweden. I think, not as much as in Brazil, but heavily. We had mandate that all gas stations needed to have an E80 tank. Even in rural areas where there were basically no cars, it was quite expensive. And many cars had engine problems because of that high level of ethanol. And everyone blamed one another. The car producers, they blamed the fuel, and the fuel producers blamed the car manufacturers. So it was an awful situation. So now the push for high levels is gone, I would say. So now it's a low blend that is sort of practiced. So E80 is dead, basically, I would say now. But if you go to lignin and convert that to an oil, you have the right chemistry. So those biodiesels and biogasoline is identical to the corresponding products from oil. So that would be something different. Then you wouldn't have these problems. They have studied that carefully, these guys. So lignin is a good source for this. But you need to justify it economically. And you have enormous amounts of other lignins out there from, we can call it ethanol type biorefining in the US and in Europe. Huge amounts. But you need to have a cleanup process. So it's a big potential there as well.
Well, I think we should not bet too much on the biofuels for vehicles. It's a commodity product. It's a low cost, first of all. So it's much more interesting to manufacture chemicals, high value chemicals. And there is another factor to be considered, is that the cars are going to turn to electricity as their fuel, so to speak. So the biorefinery's future will come from high value chemicals rather than fuels. An exception is the jet fuel. There could be a window there. of course, for the time being, you know, with the partial substitution of gasoline by ethanol, I think that it's bioethanol which is used in Brazil, I believe. And of course, you know, Brazil has a lot of bagasse and residues from cane from which it can make cheap bioethanol. But in the long term, cars will run on electricity probably, and the biorefinery should therefore think high-value chemicals rather than fuels. The panel agrees.
Yeah, I can add, it's much more intelligent, if we can, to use the wood polymers as they are. We shouldn't destroy them unless we have to, because other cheaper sources for sugars than our trees anyway.
For the past 20 years, Western Canadian forests, particularly BC, have been suffering terrible insect kill. And it's thought, has been thought that this is caused by the less extreme winters, the kind we're living through right now. I will. Western Canadian forests, particularly British Columbia's, have incredible amounts of dead wood because we have 20 to 30 years of insect kill to get rid of. Does this kind of wood, which is maybe standing dead for many years, may have to be piled up to avoid forest fire problems? Do these have any consequences for the energy efficiency plans you devise for pulping and other bio-resource extraction?
I can comment. I've been to one of those mills using a lot of those trees, and the pulp is okay. But there is one thing that is interesting. In the wood room, there is an enormous sort of dust layer because the wood is more brittle. And I think I heard that a lot of that, those trees are used for making pellets also, which is a waste of a resource. But yeah, and we had this thing in Sweden some years ago. We had an enormous winter storm, where 1 year of felling was just blown down in a small part of Sweden. Enormous amount. It was a disaster, and those trees were there for a long time, and some got over-dried, and yeah, it was an awful situation. So it was similar in a sense. A lot of insects enjoyed what happened and stuff like that. It wasn't good for other trees either. So it's not easy with those trees, and some trees could not be prostate either because they were too old, too degraded.
Well, you know, there are trees which are not used because they are residues from forest fires. There are trees which are killed by pests, by insects, but the forestry people think that those trees or this wood can also be used for chemical transformation, and people are thinking on how to harvest and process this unloved wood, as it is called in Canada. So there is a possibility here.
In terms of percentage, how much do you think it will grow over the next year, next decades, or in the future years?
Could you repeat the question?
Growth of? Yeah.
I mean, in terms of percentage, how much do you think it will grow over the next decades or over the future years?
To grow what?
The biomass industry.
Okay. What's the growth? I think the question can be phrased as what's the growth potential for the industry?
The simple answer is I don't really know. But what I know is that in Canada, you know, the harvesting is controlled. We have a good policy to preserve the forest stock, and people cannot go anymore. They might have at the in earlier times, people would go in the forest and cut trees as they wanted to use them for whatever, and it was like that at the beginning of the pulp and paper industry probably, but today, it's regulated. There is so much wood that can be harvested and no more. So the forest stock in Canada, and I'm sure in Scandinavian country in Europe, is preserved and growing, actually. I read recently, I cannot give you numbers, I don't remember, but the forest stock in Canada is growing, it's increasing, because the harvest is controlled and well managed. I'm not sure it's a satisfactory answer, but I don't think I can
more
tell you
in
more.
the business side, how much percentage will the biomass industry will grow in terms of business, and how much the impact it would be over the next future years?
Yeah. Of course, we could exploit more of the growth in Sweden, but it's a cost thing because we import some, and it's more economical to import than sort of harvest in remote areas. So we have to remember that long shipping distances are very costly. So it's a matter of making good business, and that's why some trees are left for that reason. So but in a good market, if you double the pulp price, then more would be used definitely. So the question is impossible to answer. So it depends on the economical circumstances.
And how many years do you expect to have a mature industry to transform it to product? The waste of wood transformation into product, to a mature industry product.
So I think the question is not quite clear.
How many years do you expect to do research and to end up with factories that can transform industrial size wood, waste of wood into oil or other products?
I think we have an answer now.
Okay, I think so your question is
how long it would take for
to start producing these value-added products, right?
to get it to industrial level.
Yeah, but the thing is that as one of the presentations mentioned, it has already started. Like in terms of extracting, the extraction of lignin is happening at the industrial level in Europe, Brazil, and in Canada. So we are there. So, sorry? Yeah. Sorry.
To the microphone.
Okay.
So
the transformation has already started. Well, it's slow. There is a lignin extraction plant in Sweden, one in Brazil, one is about to start up in Canada. So it's happening. It's happening at the industrial level. So we are there.
Yes, what I observed in Canada is that the industry went through a depression, so to speak, a mental depression because of the drop of the demand. So the first reaction is, what are we going to do? And are we going to simply close the mills one after the other until there is no more running? And I believe, and we went through that phase. But I believe we are getting out of it. And my source of information on that is what I saw in this week at Paper Week, which is the annual paper industry fest in Montreal at the end of January every year. And I from what I saw, the presentations I saw, the keynote speakers I heard, they are not weeping anymore. They are looking for the future with hope and enthusiasm, and to my surprise even, they are counting on the biorefinery to be part of this resurrection of the pulp and paper industry. So that's my interpretation of the mood at Paper Week at the beginning of this week. And pilot plants are being built now in Canadian mills to try, lignin. Huh? Pilot plants?
They're not pilot.
They are not pilots. All right, so they are plants. It's a matter of terminology, but yes, they are plant being built in some paper mills, but they are pre-commercial, shall we call them that? Okay, because it takes you don't go from a process as developed by in a university. As good may the university be, incidentally, there are steps until you have a plant which is producing and selling the product commercially. So we are at the beginning of a change, very profound change in the pulp and paper industry. In Canada, it's my observation.
Can I try? Yeah. I would like to be optimistic, and I am in the long term, but short term it will take time. Because we need to sort of convert volumes today for pulp and paper to something else, and that those big volumes cannot sort of be made short term. But we can make small steps. Everything starts with a small step anyway. So, but some industries have the idea that they should not work with smaller volumes. They need a bulk volume at once, and then nothing will happen. So some companies need to change the attitude. Most things start small scale. Even pulping started small scale many years ago. Paper machines. So, and lignin plants are small that are built, very small compared to the whole mill capacity. So yeah, and that is a big thing compared to other things that are being developed. And what is so sad is that we have an expensive feedstock. If you compare that to what you get agriculture, if you are for sugars, you cannot compete at all. And they're basically a waste, or they want to give it away. So we shouldn't go for sugar products, not simple sugars in a way. And it's even hard with a hemicellulose to make a good business case. It can be done in different ways, but it's hard to find good business there. So I think we're stuck to cellulose and lignin as a major sort of polymers to exploit further. That's good enough.
Okay. If there are no other questions, just before we close, I wanted to make a couple of points. One of them is I want to acknowledge the presence here of two people in particular. One of them is Mr. Trottier, to whom we owe the existence of the Institute. So I'm very happy to see him tonight here. And the second person I want to acknowledge is my counterpart at the Cette, the Institut de l'Énergie Trottier, which is at Polytechnique, has a sister institute at McGill, which is the Trottier Institute for Sustainability in Engineering and Design. And the director of the Cette of that institute is here. It's Professor Subhasis Ghoshal. And I'm very pleased to announce and remind you, those who already knew, that we organize every year a joint symposium between the two institutes. And this year will be held on March 8 and 9. So it's coming up pretty quickly. We're talking about 4 weeks from today. And we're going to have as a theme for the symposium this year, renewables. What holds us back and what moves us ahead? We're going to have a very nice set of speakers, including Mark Jacobson from Stanford University, Phil Radford, former executive director of Greenpeace, and Mark O'Malley from University College Dublin. And the event will take place here at the Centre Mont-Royal, so you know where to come on March 8 and 9, and there will be lots of information and updates posted on www.trottiersymposium.org or www.symposiumtrottier.org. So you can stay up to date there. And I'll mention a second event that will happen at Polytechnique in April, which is a presentation of the studies of the results of the study Trottier Energy Futures Project, which was a joint project by the Trottier Family Foundation, the Foundation David Suzuki, and the Canadian Academy of Engineering, and that's looking at how Canada can reduce considerably its emissions of greenhouse gases. So we will be talking about specifically Canada and what can be done to reduce GHG emissions in April at Polytechnique, with a specific date to be announced. So with that, thank you very much all for coming, and we can close with thanking our presenters for the evening. Thank you very much.